Hello, hello. Good afternoon. And thank you very much for joining this session, which is called Help MRP Slow. As it may or may not be obvious from the session title, the purpose of this presentation is to introduce you to a flow, a sort of methodology that you can use whenever you are experiencing MRP runtime issues. My name is Roxana Diaconu, and I am the program manager, Dynamics CX program manager, responsible for master planning. And today with me is my colleague Dennis Conrad, who is a developer in the team that is developing and maintaining master planning in Dynamics CX. Before we begin, I would like to mention that we would like to take questions at the end of the session, and that there is a mic. So you can. I would like to ask you to go to the mic and ask the question in the microphone. So before we begin, there is some things that I would like to make sure are understood by everybody. First of all, runtime and performance is not the same thing, and this is not a session about MRP performance. It's a session about MRP runtime. What I'm trying to say is that, for example, you could have an MRP run that lasts for, let's say, 5 hours. You could say the runtime is not good, but taking into account the BOM complexity, the number of items, the run being intercompany or not, it could be a run that is performing well. Also, I would like to mention that this is not a session where we will be presenting let's say, sort of benchmarkings in the sense of if you have this many items, if you're running on this hardware, if this is your average BOM level, this is how long your MRP should be. It's very hard to do that, and we're not going to go there at all. First thing that's important to mention and important to acknowledge is that MRP is an engine that is very generic. It's made to support multiple industries and business processes. What I mean by that is that if you look at the actual code that gets run, you may see that there are routines that might make no sense from your perspective, but some parts of it are needed in order to keep the engine versatile and keeping the engine usable in different industries and so on. Second thing that we should get straight is that when you are implementing Dynamics CX, you should think of MRP runtime from the early stages of the implementation. Why is that? It's primarily because improving the MRP runtime is a trial and error game. There is no silver bullet, and troubleshooting the runtime, reducing the runtime is a process that can last up to a month, maybe even more. So please think about it as early as possible. Something else also related to implementation, a Dynamics CX implementation project. Please set aside time during the implementation for evaluating and improving the MRP runs. So kind of set a goal for your runtime. How long should it take based on your business processes? For example, if you know you need to replan twice a day, of course it cannot take longer than a couple of hours. And after you have set these goals, set aside time during the project to track against these goals. What I'm saying is probably for a lot of you sounds very obvious, and you may wonder why do I keep talking about it. But we've had a lot of cases with Microsoft when customers call us, 3 weeks before go live, that their runtime is very long. And there's really not much we can do at that point, although we really do try. But it is, like I said, a trial and error game. It takes time, and basically what I'm also trying to say is that we're also asking you to be patient with us when such a case gets to us. And also be patient inside your own organization. Things take time. And last thing before we begin, data composition and business needs change, and so does your MRP runtime. So this flow that we're going to present today, this methodology, is most likely not something that you will do once when you implement AX and then forget about it. It's something that you have to go through every time you upgrade, new CU. The more items you add to master planning, the more warehouses, the more bombs you add, you will have to go through this process over and over again. Now, that said, the agenda for today is basically this flow that I'm mentioning, the steps you have to go through when troubleshooting MRP runtime. So first, we're going to talk about a set of steps that we call out of the box, meaning that we're going to start by presenting a set of parameters, a set of how to run MRP rules, but nothing that has to do with SQL Server queries, changing the code, customizations, so just out-of-the-box solutions. The methodology would be that you go through each and every step that we're going to present, each and every parameter. You apply this parameter on a test environment, which preferably is very close to the production environment in terms of data setup, but also volumes of transactions. Now, after you have applied this parameter, you should check the effect it had on the MRP runtime. If it has a positive effect, you should also do a set of functional testing to see that nothing has changed functionally on the environment. And then it's a good idea to, if the runtime was improved, it's a good idea to apply the parameter to the production environment. Also, once you make a change, an out-of-the-box change, we would also recommend that you keep a log, also so you know what you have already tried, but in case nothing helps and you will get to the open a case box, we will know what you have already tried and it didn't work. So, apply a out-of-the-box step. Did it work? Yes, no. Move it to the production environment. Now, once you are done with all the out-of-the-box improvement suggestions, then you will have to go to the blue box, which is troubleshooting MRP. So troubleshooting the runtime. Meaning that you will have to use a set of tools to do SQL Server analysis, for example. And the outcome of this troubleshooting phase will most likely be changes either at SQL Server level in the X++ code. And it's also something that's an iteration. Try one thing, try a second thing, see if it improved the MRP runtime, yes, no. It's a loop. So after you have tried all the out-of-the-box rules, you have troubleshoot MRP and there was nothing, then you go to the yellow box. You're going to open probably a case with Microsoft. And towards the end of the session, I'm going to talk a bit about how we would like our customers to open cases for us so we can faster react on them. So that said, I'm going to start by going through the out-of-the-box things you can try to improve the MRP runtime. And it's also a good idea that you also keep this sequence that I'm going to go through now. So first of all, before you start the MRP runtime troubleshooting flow, you should think about planning your MRP runs. What do I mean? First of all, hardware setup. You need to ask yourself, am I running master planning on the good enough hardware? MRP is very chatty with the database. So if there is you have to ask yourself, do I have a latency in connecting to the database? You can consider solid SSD drives. They will help for sure. So after this first step, do I have the right hardware? Next thing to consider is to run on multiple AOS servers and parallelize MRP. It's a very good idea to have a dedicated AOS batch server for running MRP. I will get back to that, but it's important to know that in data compositions where there is lots of items, but that are not coupled together through bomb structures, so lots of independent items, MRP scales pretty well. So you can for sure parallelize it, and you will get better performance, better runtime. The last thing to consider before you run MRP is to make sure that you're running one routine at a time. So kind of not plan the MRP run, but plan all the other batch jobs that are running on your system. We have had lots of cases where people were running multiple routines simultaneously with master planning. They seemed unrelated. For example, one of the latest customers' escalations about runtime, they were doing some retail merchandising routine, but it happened to acquire a lock on the item table, and then MRP would have to wait for this lock, and it would take 6 hours instead of 1 hour as it usually would. So please try not to run a lot of other routines with master planning, and think whether these routines will impact the MRP performance or not. And of course, it goes without saying, don't run multiple heavy routines at the same time. So that is the part about planning the run. After you have planned the MRP runs, basically install hotfixes. So hotfixes are your friends. You're probably not the first one to experience an MRP runtime issue. I am aware that our CSS channel, the engineers in the CSS channel, they have a list of MRP issues that have been fixed already, and it's very easy for them to see what KB you have installed or not. And if you want this list, just contact them, and they can share it with you. But if you want to find the KBs that we have released already, partner source and customer source is available for you. Also, very important to mention, don't apply on the production environment directly. Apply on the test environment, and if you see a runtime benefit, move it to the production environment. Okay, so you have planned the MRP runs, you have installed the hotfixes. The next thing you can do is start going through these rules for running MRP correctly. These rules are available online, as you can see here. So they are published on the manufacturing team's blog post. You can follow the link in the PPT and you will get here. For each rule, as you can see, we have a description of the rule. What does it do? We also have links to the KBs that we recommend that you install for each rule. But what I would like to do today is what I'm going to do today, I'm going to quickly just read them through. And then I'm going to go a bit deeper into some rules that I think are important. So rules for running MRP correctly. First of all, use helpers for running MRP. Second of all, the number of helpers used during master planning needs to be less than or equal to the maximum number of threads allowed on the batch server. I will get back to helpers and bundles in the next slide. Third rule, a very important rule actually, configuration keys that are not actively used should be disabled, and I'm primarily talking about the process industries configuration key. Due to the nature of process industries, MRP is doing a lot of things that if you don't use, maybe disable the PI key and everything will start going faster. Action and futures message usage. especially about action messages. Action messages are the suggestions that improve the result of the plan, but there are lots of customers that don't really use them. But it's important to understand that calculating these actions is a very lengthy and complex procedure. So if you don't use actively the action messages, if you don't look at these suggestions and apply them, then consider removing them from the MRP run as a whole. Also, when you're in an implementation phase, it may be a good idea not to tell the system to generate improvement suggestions for all the items. So, for example, when you start implementing AX, enable action message generation only for the problematic items, the items with long lead times, with high cost prices, things like these. It will have a good impact on the runtime of MRP. Kind of same goes for futures messages. The futures messages are the delays. So during the futures phase, MRP is propagating delays from lower levels to higher levels in the BOM. If you're a manufacturing company, it's not easy to get rid of this delay propagation. If you are retail and distribution, maybe you can consider living without it. It's also a lengthy operation. To give you an example, again from a customer escalation, a retailer, by disabling actions in futures, the runtime of MRP was reduced by 2/3, because MRP was kind of taking exact the same amount in coverage action in futures. And the funny thing is that they, at that point in time during their AX implementation and their AX life, they didn't even know what action messages were. And futures were not really relevant for their business processes. So consider disabling them. The next rule is about number of tasks in an MRP helper bundle. It's not really a rule, because I will get back to that. I will get back to this rule in the next slide. So let's move on. Last thing, very important, is that in the master planning parameters, there is a maximum cache setting, and we recommend that it should always be set to maximum. We're actually planning to remove this setting in the future versions of Dynamics AX. So that's a set of rules for running MRP, and as I mentioned, I would like to go a bit deeper in talking about helpers, specifically how many helpers you should use, and bundles, and that's how many, what should the bundle size be. So how many helpers? First of all, the helpers are the parallel threads that help running MRP in parallel, obviously. How many? Well, in retail and distribution, where we assume there's lots of independent items, you can use many helpers, like I already said, because there's no dependency. There's no one subcomponent in lots of BOMs or something like that. Now, if you're a manufacturing company and you have lots of BOMs and shared subcomponents, you cannot use a lot of helpers. You should use less because of this dependency between the items. Bundles. So first of all, what is a bundle? The idea is that an MRP helper takes a bundle of items and takes these items through an MRP step. An MRP step is something like doing coverage calculation, doing action messages calculation, doing futures messages. So how many items should a thread take? Unfortunately, there is no magic formula for determining that. But what's important to know about the bundles is that they are in memory. So too many chunks will decrease the performance of the system due to memory hogging. And something that we learned on customer environments is that, so we had, they had BOMs. And their items, of course, the item number, it had a meaning. So similar items that were very complex had similar names. And what was happening is that a bundle was taking a helper was taking a bundle, and this bundle contained all the complicated items, all the deep bombs. And this helper was processing these high complexity items for a very long time, and all the other helpers were sitting and waiting for this one to finish. How we can solve this problem, how you can solve this problem, is try to introduce some sort of randomization in the MRP logic, so that when a bundle picks a group of items, they are randomly selected. Either use recID, for example. That's something that it's a fix we made, but it may not work if the items are still created, inserted in the database in the order of their complexity, kind of. And this can happen when you're migrating from another system. What we are going to show you later on is how to create a report that tells you which are the items that are most heavily processed by MRP. So you can take this report one step further and see what bundles, in which bundles are usually these items processed. And if you see that it's in the same bundle, then definitely introduce some code to randomize this and make sure they are processed by different threads. That was all about rules for running MRP correctly. So the next step is rules for setting up planning parameters. Very important to mention, these setup rules are all about improving runtime of MRP. So I got a question from a colleague of mine who was saying, okay, but if I do that, doesn't it mean that some sales will be delayed? And the answer was yes. So if SLAs are important to you, some of these rules may not apply. But remember, this is a session of MRP runtime. And the purpose of these how to set planning parameter rules is that creating planned orders is it's a heavy process, especially if they need to be scheduled and so on. So all this, what these parameters will do primarily is reduce the number of planned orders that are getting created. This has a performance, a runtime benefit. It also has a planning benefit, you could say, because it potentially can introduce less noise in the plan. It will also make the plan easier to analyze, since there is less data to look at. So I'm going to just read through these rules, and the next slides are going to go deeper into the relationship between some of the parameters and some other settings. So first of all, items assigned to the same coverage group should have similar lead times. I'm going to explain why is that important. Next thing, master planning parameters use dynamic negative days parameter. This should always be checked. I'm going to again explain why. Negative days parameter on the coverage group should not be less than the lead time of the items assigned to the coverage group. And from this rule, it already starts being clear why items in the same coverage group should be of similar lead times. Because the negative days parameter, which is connected to the lead time, sits on the coverage group. Then positive day parameter on the coverage group should not be left empty and should not be set to 0. And I'm going to explain why. Items that are regularly produced or procured should be assigned to coverage groups where the positive day parameter is equal to the item's lead time. We're going to go through that as well. And the last thing, you have to make sure what your settings under scheduling parameters are. I'm not going to discuss about it in this session, but on the blog post, I explained how the optimization works inside the scheduling engine. So the last point is only for production order scheduling. And I'm not going to go into details about that. But be careful that if you have a long-running optimization set, you will be losing a lot of time in production scheduling during MRP. So that said, the next slides are all about the relationship between the dynamic negative days and the lead time of the items, and also why you should always have the use dynamic negative days checkbox checked. What basically what this will show is that if these are set correctly, you will not create additional planned orders. So in the first slide, the free slides are because I want to show how this works when the demand comes at the beginning of the item's lead time, during the item's lead time, taking the baseline as today, and after the item's lead time. I'm working with purchase orders and purchase lead times just for simplicity. So in the first example, we have an item that is purchased. The lead time, the purchase lead time of the item is 6 days. It's the the purple line. Then we have a sales order coming in on the baseline, so let's say current date. And in the system, we have an existing purchase order, which is 7 days from today. Now, let's assume in the system your negative lead time, your negative days, sorry, is set to 2, which kind of has no connection to the lead time of the items. So what will happen in this situation is that when trying to find receipts for the sales order, master planning will look within the negative days time fence. It will not find anything, so hence it will create a planned purchase order. This planned purchase order will automatically be delayed based on the lead time. So essentially the planned purchase order, sorry I shouldn't have clicked there, the planned purchase order will arrive at the end of the lead time fence. Now, if you use dynamic negative days that take into account the lead time of the item and your negative day settings, what will happen is that the actual time fence where master planning is going to search for receipts for the demand gets extended, takes into account the lead times of the items, and all of a sudden it will find the existing purchase order that you already have. So in that case, this new planned purchase order will not be created. This improves MRP runtime, and you could potentially say it also simplifies your operations. It is true that it introduces a delay. One sales order is not going to be shipped, is going to be shipped later than the lead time of the item. How are the dynamic negative days calculated is based on a formula that's in this slide. You don't have to try to read what's in there because the slides are going to be available online. Now, next case is when the demand comes within the lead time of the item. It's the same situation. You have negative days set to 2. A new planned order is going to be created. The new planned order has the order date today, but it gets automatically what we call future set, so it gets automatically delayed. But if you use dynamic negative days, the red line is your actual time fence, which you look for receipts. So MRP is going to pick up the existing purchase order that you have in the system. No new planned order is going to get created. Hence, again, improvement in performance and potential better plans. No need to try to read what's in there. It will be available online. And the last situation is when the demand comes after the purchase lead time for the product. And again, you have an existing sales order. In this case, basically, the using or not using dynamic negative days has no impact. A new planned purchase order is going to be created anyway. But the point is, well, since it works exactly the same, and in the other two cases it was a good idea to do it, you might as well just always have it set to true. So that was about dynamic negative days. Questions are in the end. dynamic negative days, and the lead time of the item, and why they should be, why should items with the same lead time be in the same coverage groups. Moving next, positive days. So the purpose of this slide is to demonstrate why you should never leave the positive days to 0 or not set. Let's assume that you have 2 purchase orders, the blue arrows, and a sales order. Your positive day parameter is set to 0 or left blank, meaning that master planning is not going to look for any receipts backwards from the demand date, from the sales order date. So a new planned purchase order is going to be created, and that's it. Now, if you do set the positive days to something, you can potentially pick up existing receipts and peg them against the sales order, hence making a planned order, making the planned purchase order irrelevant. And the last slide around this whole positive days, negative days thing, it's about positive days and lead time. Why should the positive day setting be close to the lead time of the items inside the coverage group? We have the same situation as before. We have 2 purchase orders. We have a sales order. The negative day setting is set to 2. Which means that, okay, a planned purchase order is going to be created. And it can potentially have a delayed delivery. Now, if you have 5 days of purchase order lead time, and your negative days are close to this, to the 5 days of lead time, MRP will look for receipts inside the lead time of the item. So those 2 purchase orders will be considered to fulfill the demand. So to summarize, I guess the point is you would like MRP to look backwards within the lead time of an item, because even if it doesn't, it will create a planned purchase order which is going to be by default delayed, assuming there is no on hand. So that's all about positive days and negative days and lead time. This is probably a slide that you have seen many times before. It's about the relationship between the time fences. In MRP there is lots of time fences all over the place, and it has a very good performance impact, a very good runtime impact, if the relative size, let's say, is in the chart here. So of course the shortest time fence should be the firming one, then the freezing, then calculating delays and suggestions, then considering capacity for production, and then doing explosion and doing coverage. Any other mix will potentially slow down and confuse MRP quite a lot. Now, that was all about the out-of-the-box rules. So as you can see, it was nothing about code. It was just about setting parameters. I would like to mention again that none of these rules are to be applied on the production environment. And all these rules are for improving the runtime and improving the runtime only. So use with care if you have requirements such as, SLAs and stuff like that. So if nothing of that, of what I already spoke about helped, we will go into the MRP troubleshooting phase, where you're going to be using tools and stuff.
Yes, thank you. So in this section, as Roxana mentioned, we're going to be looking at what you do when you sort of tried all the out-of-the-box stuff and you're still not satisfied with the runtime. So the first thing is to sort of set some expectation as to what kind of trouble are we actually looking for. Well, that can be a number of things wrong. It can't be that the parameters that you set up is actually not optimal. We as part of the troubleshooting, we may discover that you're actually not using a set of parameters the way it's intended. It can be that there's a problem with some of the SQL statements or constructs that are executed against the database. It can also be that the actual setup, so the indexes or the caching for a given table are not optimal. It can also be that there is some suboptimal implementation of a given algorithm. So what we've tried to do is that we tried to wrap this section around an actual escalation that we've had to the extent possible. So how do you go about this? Well, you use tools. And this is what we're going to do, I'm going to present now. So a quick overview is the first one, master planning session log. It's not so much a tool, it's actually a feature that's already in the product. It's a form. It has some limitation, and we're going to show you a few tricks as to how you can improve what it's doing. The second one is the performance analyzer. Some of you will know this as Dynamics Perf. What this is it gives you the opportunity to monitor your runtime, even across batch servers, so parallelization. It takes on the view of what is being executed against the SQL server. It has some limited tracing capabilities as to the metadata of the AOT. But it is most likely if you run into issues as a developer or technical person, you'll need to use this tool. So for instance, the case that Roxana was mentioning earlier, where you're running both some retail operation and you're running MRP, this is the kind of tool that will give you an indication of the kind of problems you might run into. The third tool is the trace parser. So this is when the tool you use when you've narrowed down the issue to a pretty simple scenario that you can execute within let's say maximum half an hour or something like that. It's not 10 or 9 hours repro steps. It's not suitable for that. And finally, the SQL profiler is something you use when you're down to a few lines of code and perhaps you're trying to understand what the SQL statements that this code is actually generating, that the kernel is generating. So starting with the planning session log, the important thing to use this form for is to figure out how is the processing time of MRP being distributed across the various tasks or steps in MRP. So what you should expect to see is that the first step, which is simply updating the plan, should not take more than around 30 minutes. Coverage is one of the heavy processes, and that is where you should be spending a substantial amount of time. And likewise with action and future messages. And also, as Roxana mentioned, if you're not really using these messages, you'll definitely be made aware of here that you're actually spending the time on calculating the messages. Also, copy plan, and copy plan is not supposed to take a long time, but auto-firming may take some time. So let's jump into AX and take a look at the master planning form. So it's actually located under setup. So what we do is that you select the plan. So the plan I've been running is number 20, the dynamic master plan. And as I open this form, I can go to statistics and see the numbers here. So bear in mind that the actual escalation here that we're using has been greatly simplified in order to be suitable for demo purposes. Once you go up to the processing task, and I should remember to mention that you need actually, in order to be able to use this, you need to set this parameter on your MRP run. This will calculate the processing time of the given task during the MRP run. So what this form is telling us is how the different tasks, how much time or duration we're spending on each of the tasks, and related to the given step in MRP, but also on the different items in MRP. And ideally, what we would like to do is that we want to sort of get a feeling of like which items, are there some items that are potentially taking longer than others? Are there some complex items, and are they potentially ending up in the same order bundle? Because then it might be an indication that we need to do something to make sure that the most complex items are being put in different order bundles in order to leverage the parallelization. But as I mentioned, you cannot sort in this form by duration. So what you can do is that you can go to SQL Server, and then you can simply do a small select statement against the underlying table of the form using the process ID of your MRP run. So as we see from the select statement, the items that are in the 20,000 category seem to be the ones that are most long running. And now Roxana will show you a different way, and even a more cool way to do the same thing.
Well, it's a nicer way. What I'm going to show you is basically how to build reports that graphically display the same data that Dennis showed in SQL Server. So this is a Power Pivot report that shows top 10 items per total duration among all the MRP tasks, and it also has a split in between the exact MRP task that happened. So what I did here is I added the table called recalc_trace, something like that. Dennis, do you remember the name of?
Recalc_trace.
Recalc_trace, yeah. So I added recalc_trace as a data source for the pivot table. Then I had to add another column, the duration, which is calculated from the end time and start time. I had to add another column for the task to give it a nice, meaningful name, because by default my table was using the values of the enum, so not very nice. And after I did that, I just clicked on Create Pivot Chart, and I got this really nice chart, to which I added a filter for process ID. So what that allows you is to kind of get a view of the overall historical long-running items, but also kind of troubleshoot per run which item took the longest. I added item to the report, I added the tasks, and I just created a top 10 view fields, yeah, top 10. So basically I get the same result as Dennis. I'm going to make this a bit bigger. In my report, as in his, the 2,000 items seem to be the top 10 long runners. One thing you get from here, it's a clear indication that there is something wrong with item number 2001. As you can see, it's taking a considerable long time in coverage calculation. One extra thing to mention is that you can take this report a step further. So in the data source for the report, you have the bundle. The bundle ID, where is it? This one. Well, the IDs are a bit strange with the bundles. So you can also see if all these items, the top 10 running items, are in the same bundle or not. And if they are, you should consider making sure that next time, or when you run MRP in general, they're not processed by the same thread. So Dennis is now going to show you what you do, how you troubleshoot this long-running coverage.
Yes, so we were lucky in this case, and we already have an indication that something is wrong with this item. That is not, unfortunately, not always going to be the case. So going back to the demo, just quickly recapping. What you're using this form is to identify the tasks which are taking, or the items which are taking the longest, and checking to see if the items end up in the same bundle. You can use SQL to do this to get the duration and make it easier to find the items, or you can use the Power Pivot approach. The next tool is the performance analyzer. And as I mentioned, this shows how a SQL server is spending its time, what it is executing on. So you can see which SQL statements are taking the longest. And really important, you can see which SQL statements are waiting. So when they're waiting, they're not actually doing what we want. They're not doing MRP for us. They're waiting on something else. And in the retail example, this is where in the box on the right side, this is where an alarm bell should go off, that you're spending 30% of the time waiting on something else, and you're not spending it on adding value to the process. So there's a link in the bottom to how to set this up. There's been a new version of this that also allows you to have a baseline run, so you can compare different runs. This will be good if you at some point reach the state where you're really happy with your MRP run. If you use this tool and make a baseline, you'll be able to compare that later on if something changes with the MRP run and you become unhappy, so to say. The good thing about this one is also that it's the overhead of doing this trace is quite limited. So you are able to do it on really long runs, like even you have an MRP run of 9 hours or something like that. So the trace parser. So returning to the example of the item which turned out to be long running, which was quite unfortunate. So what you would do is, what you would try to do is that you would use the trace parser. And if you're not familiar with this, so this you can install this with AX. And if we open up the development environment, under Tools, there is a tracing cockpit, and you can start and stop the traces. You can start the trace, run your scenario, stop it, and then open the trace. So I've done this already because it can be quite a time-consuming process. And even though this is the very limited demo data, the file grows pretty quickly. So it easily becomes, I think it's 1 gigabyte currently, just for this quite simple example. So if I show you the trace from running MRP just for this 20,001 item, what we can see is we can have a drill down of the different code being executed. So we see that a bunch of stuff is just very minimal. It's clearly not the issue of why MRP is taking so long. So we can put in a filter to sort of get down to what's really going on. And then we can start to drill down into the execution to see where the time is being spent. We can also go to the X++ and RPC tab. Here we can see which processes are taking the longest. And something pops right out here because we are spending apparently the most time on doing a bomb circularity check, which is something that you do if you change a bill of material. And this is should be sort of unexpected. You shouldn't be doing that. So the reason for that in this example is that the 20,001 item is an item that is controlled by the product configurator. So when you create a sales line, you take this item and you configure it. What you will be encountering is that the product configurator will be generating a new bill of material for this item. And by default, this bill of material is not gone through a hierarchy check because that would leave the process on the sales order processor, which is even more delicate than MRP. So what to do about this? So when we discovered this issue, the first thing we did was we disabled the check. This can lead to some other problems, but now with CU8, there's actually been introduced a new parameter. So if we go to inventory management, and we go to the parameter section. We now have two ways of checking the circularity of the bomb. So one is low complexity, and the other one is high complexity. And where high complexity sort of, where you should consider using that is if you have very complex, deep bombs and wide bombs. Typically, if you're using the product configurator, it goes very well with that for the high. If you have products that are not that complicated, you can go with the traditional one, which is named low complexity. The difference between the two is that the low complexity is traversing the bomb structures using the database, where the high complexity one is fetching all the bomb structures and putting them into memory and then traversing the memory structure instead. But for low complexity bombs, this doesn't really pay off. So if we go to our second trace, so this trace has been made now with the new check. Again, I'm not doing this because it takes several minutes to run it. What we'll notice here is that under the X++ and RPC section, the circularity check is now no longer to be found on the most expensive tasks. And if we go back to the nice report that Roxana made, and we check a run that is made now with the high complexity setting on, what we'll see now is that the different tasks are more evenly distributed, and the 20,001 is not even showing up as the most time consuming. Okay. No, so it's. I'll answer the question now. So the question was, what have I done? So what has been done is that a new circularity check algorithm has been introduced, and what that one does is that it doesn't do the same as the old one, which traverses the database to check the circularity check. Instead, it gets all the bombs into memory. It builds a graph, and then it runs. Basically a component search algorithm to check if there are any circles in this directed graph. If it finds a circle, then we have a problem, because that'll cause an infinite loop in running MRP. Yeah, so what this tool allows us to do is it allows us to examine both X++ execution and SQL statements. It can very well be used together with the performance analyzer, because that one will just give you the SQL statements, and then afterwards you're left with the task of mapping that SQL statement to the X++ code. And it has this drilled out. So when to use this, you typically use this when you have a good idea of where the problem is. And that's mainly because there's a substantial overhead in the file it's generating. The final tool is the SQL profiler. And we typically use that when we have narrowed down the issue to a few lines of code, and we're trying to understand what SQL is being generated for these lines of X++. And then we can go in and examine if we need to tweak anything in order to get some more optimal SQL being generated. And the reason for that is, so the reason why we only use it for a few lines is that it's quite chatty. So let's see if I can find this. So if I just start it up, even though I'm not actually doing anything in AX, it's actually the kernel is actually executing quite a number of SQL statements. So typically you'll have the debugger on, and you'll go to your line and then move the cursor and trace what is being generated and then analyze it. Yes, so when to use this, as I said, you've limited now the issue to a specific line or a couple of lines, and then you want to examine the created SQL statements.
Okay, so we have reached the point in this methodology where you have tried all the out-of-the-box things. You have tried to troubleshoot the run on your own. Nothing worked. So it can be that you encountered a bug, or it can be that you need help from Microsoft. And in order to allow us to faster help you, I'm going to go through a certain, again, rules, steps, in how to open a case with Microsoft to ensure that it gets processed and dealt with and closed as soon as possible. So first of all, when to open a case? Well, after you have done all that we showed you so far. The reason for that is that basically when we start dealing with the MRP MRP runtime issue, this is exactly what we're going to do. So now that you know how to do it yourself, you might as well try to do it. How to open the case? Well, cases such as MRP is not performing. Okay, so we cannot do much about it. Try to identify the concrete issue. So what Dennis showed in with the last tool, you can narrow down the problem to a few lines of code, to a method, to a query, to something. A case saying that this method is taking so long time in these circumstances is much more helpful than a case saying MRP is slow. Be descriptive, be precise, and give the background. The risk of not being descriptive, blah, 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 is that your case is going to get pushed back. You will risk long waiting times while we try to find out, okay, what's your problem? And you also get the risk of, you enter the risk of getting the wrong fix suggested back to you. As I mentioned, our support organization has a list of hotfixes for MRP improvement. And I know that some of our escalation engineers, when they get the MRP slow case, they just say, okay, do you have this installed? No, go install it. So if you're not precise and if you don't describe to them what's the actual problem, they will just send you some fixes that they think may help. How can you give? So if you remember, I mentioned that whenever you try an out-of-the-box solution, keep a log, and when you open a case, send us this log. So I tried this, it didn't work. Then I tried that, it didn't work. So it's much easier for us to know exactly what you've done so far, so we don't try the same thing over again. So that was how to open a case. What to provide part of the case? Upon opening the case, we need a proper justification of the business case, meaning that you cannot say that you are configured to order and you have hundreds of bombs and deep bomb levels, and you want MRP to run in 1 hour. We will ask, okay, why? Then we need a clear repro. We need an insight into the data composition and the business processes you're running. We will need to understand your parameter setup, so all those out-of-the-box things that I mentioned. We will need to know how many helpers you have used. If you have used the tools that Dennis showed, we need the traces and the profiles that you collected. Also, upon opening the case, we need to know what customizations you had, because there were situations when we jumped in solving a performance, runtime, keep saying performance, a runtime case, and it turned out that the problem was not in standard AX code. The problem was in the partner's code. And, well, it's not that nice for us to find that out. While the case is being, upon opening the case, that's what you need to provide us. Once Microsoft starts working with the case, especially if the part of Microsoft involved is the R&D team, so the development team, not escalation engineering and not CSS. We will need a test environment with data. The data has to be as close as possible as the data you have in production. We will need a VPN and corp access, potentially, because we will need to do and go potentially these steps on your environment. We will need someone in your IT department that we can contact. at all times, well, at our times at least. We may need to schedule meetings and SimCap calls, so be prepared for that. And in case we need to go and see code, data, we need NDAs and stuff like that. So that's why if you don't want to go through all the trouble of NDAs, that's why it's important to have a test environment with test data that is close to the production data, but it's not your actual data, so we can look at it and do whatever. That said, okay, why can it take long? I don't know if any in this room, any of you in the room have opened a runtime issue case with Microsoft. If you have done, you probably experienced not so fast return from us. Well, it's because there is a long chain. So from the customer, you go to your partner, the partner goes to CSS. If CSS cannot figure out what's the problem, they go to sustain engineering. If sustain engineering doesn't know what to do, they come to the core team, to the R&D team. And you can imagine that all this communication is already maybe even more than a week. Then something else that we experience takes a very long time is accessing the environments, the VPNs, accessing your test environment. If you're not ready, we will have to spend a lot of time, also again, just 1 week, trying to connect and debug what's going on your environment. Yeah, why can it take so long? Whenever we provide a fix, we try to make sure that we don't break other things. So the whole testing is taking a lot of time on our side. We don't have enough resources. So actually, well, there's a lot of teams involved. None of these teams have a lot of people. Sometimes the core team runs in 3-4 developers that are not, their primary task may be something totally different. So our resources are actually pretty limited. And we're just trying to do the best we can and be as responsive as we can with the resources we have. You will probably get a time frame when this is possible. So sometimes we can get back to you saying, okay, now we're in the middle of preparing for the next release. That's due in January. After January, we start working on your case. So why can it take so long? Next thing, what to expect as a result? It's not necessarily a hotfix, a KB article. So you can get indeed a hotfix if it turns out that we find a bug in the product. This is a good case because a hotfix is something that is supported by Microsoft and tested, and it will be automatically integrated in future releases. So on your side, there's no maintenance once you apply the hotfix. We could provide you with a private fix, which is something that addresses a customer-specific case. This will not be supported in any other release. So it's the customer that has to make sure that this is upgraded, ported to future releases. And also, if we provide a private fix, we are not testing the private fix. So it's the customer and the partner's responsibility to do that, while hotfixes are tested by Microsoft to make sure that they work. We can also suggest you a workaround, or we can decline and say, sorry, we're not going to fix. We're not going to fix this. It's either by design or you're not using the product the intended way. And well, basically that was it. So now we are opening for questions.
Oh,
yeah, and you have to go to the microphone. Sorry?
But it's for the recording.
Okay.
Oh.
It doesn't work?
Hello?
Yeah.
Hello?
If your items don't have an positive days to 999?
It's because you will be looking 999 days in the, so you have a demand on day one. Do you really want to look 990 days back? How to fulfill this demand?
I thought it was if the demand is 999 days out.
I think that's a sorry?
If the demand, well, the positive days is how long is your inventory going to be valid, or how long is the expected receipt going to continue to be valid? So if it's not cheese or wine.
Yeah.
The goal is to not create a planned order, right?
Yes, the goal is to not create a planned order.
So if you make it 999 days, then any, and positive days even works with inventory, right? If you go out more than the positive days, on hand will be ignored. I've tested it, trust me.
Okay, but the thing is, master planning, so the runtime thing, the code will still go through all these days and look for receipts. So it will work, but it will still not be fast.
Okay.
It will be slower.
All right. Can I ask you a second?
Yes.
On negative days, right?
Yes.
I think it's important to note that even if you are having it come in too late, you are going to get an action message if you've got action message switched on.
Yes, you
right?
are.
So you got a warning that AX is going to use that incoming order. I think it's also important to note that negative days is completely irrelevant if there's no existing incoming order.
That is correct.
Right?
Yes.
Also, if one of the things I advise my clients is that if you're not using action messages, I want you to promise me that you will look at your net requirements for every suggested planned order. And if you're doing that, if you do set a negative days, you're going to get no warning, and you're not using action messages, that's the premise. There's no warning that it needs expediting. So under those circumstances, I actually advise my clients set the negative days to 0, because at least you will get a planned order at a date you know you can't do it. That's going to, and you're going to look at the net requirements because you promised me, right? Yes. And that would slow down MRP. I understand that, yes. Right? What I also advise them, and this is where you may disagree with me, don't set it to the lead time. If you are going to read your action messages, set the negative days to 999 as well.
This is again correct, but
it will look further.
MRP slower.
Thank you very much.
So I tried to explain it at the beginning. All these settings are when you are, it's not fast, it's not as performant as you would like it to be. But I did mention that you are going to have functional impact if you do that. And from a functionality perspective, it may not be the best thing to do. But if you don't have this negative impact, try to use these guidelines that we have. Thank you.
Hello. This is regarding helpers. There was a kind of, not benchmark, but an idea of how many helpers to set. And that was related to the number of cores that the batch server has. Is that accurate? I mean, is that the recommendation to take into consideration the number of cores that a server has, or what is the recommendation to put the number of helpers to have to make work correctly? Because obviously if you have many helpers and in a small server, it could be it could be a worst scenario. So how many helpers according to the batch server? Thanks.
So the recommendation was about if you go to AX, let me just switch back here. The recommendation was related to, where is it? System administration, and then you have system, and there is server configuration. And for each server, you specify this number of maximum batch threads per server. So you cannot ask for more than, in this case, this is a simple case. I have one server and the maximum batch rate is 8. I shouldn't ask for more than 8 helpers, because 8 is kind of the max. But you can have multiple, you can add multiple batch servers there. So at least that's what I think, to be honest.
Okay, okay. It's more in terms of the hardware that customer has.
No. No, the rule has nothing to do with the hardware. It's only about these settings, as far as I know.
Okay.
I'm pretty sure there's nothing hardware related in that rule.
In previous versions, I remember to have a kind of measure that if you have 8 cores, you only are available to have 8 threads, or I don't know. There is a calculation there, but if
it was the case in the previous, okay, but this recommendation does not refer to that.
Okay, in current versions, I mean, just depends on that number.
Yes, it was about this number.
Okay.
But we may need to create another recommendation if we had one previously about the course.
Well, I have one. Maybe I can review it with you later.
Yes, yeah.
Sure. Thank you.
Sure. This list is not something, you know, it's something we want to keep on updating and keep on working on.
Have a couple of questions. So the first one, mostly technical, but you had a setup where you changed the low complexity circularity check to high complexity, and that's available from CU8.
Yes, that's correct.
We probably have a similar situation, like, you know, we don't know for sure, but do you think, is that something we can try in a CU7 environment, like upgrade that just for this particular fix and try that? The customer has a lot of other modifications, and usually when we upgrade, doesn't go all that well.
I mean, you can try anything, I guess, but
because that kind of solved or probably moved the load on 2001 item to, it's just spread the issue,
so
I think.
if at all possible, if you can create a test environment where you can verify that this makes a difference for your customer, the ideal thing would be to create a case requesting this feature for the version that your customer is on.
So, okay.
Then it can be backported to that version.
You mean like create a ticket separately for this particular functionality?
Saying that you need this on the R2 version.
Okay. And there was one suggestion on do a random selection of items, and you mentioned that Microsoft used record ID. Like, if we were to try that, what are you suggesting exactly? When the MRP queries with the items, do you want us to add an extra condition to, like, create an extra field and introduce a GUID or something?
That would be one option. So right now they're put into a local data structure, and you could also randomize the way you read them or put them into different groups.
Okay.
Like that. But it would be an easy implementation, at least in my opinion, to add a field to the table where it's read, and then sort them by this randomized field.
Assuming that the item IDs are not randomly created, right? Okay. And we have just the last one, and it's also from our system expert. So we have done a lot of trace parser experiments before, like tons between all our less complex and more complex customers. We do get tons of data, like several records of which code goes where. Do you have, especially tackling MRP runtime, do you recommend us to look in a specific area? Like, we get too many lines and sometimes we're just lost, and we do come to Microsoft without narrowing down.
So when you say lines, what are you referring to?
The data that we get, like how many, where it takes what time, we get a lot of those data. Do you have
maybe I'm not sure I completely understand. So in the trace parser, everything is taking a long time, or?
Yes, not that everything's taking time, but a lot of areas. it's not restricted to just one line like you showed us. That's not typically the case. We have like moderately distributed processes that run across like these classes and these queries. So do you have for MRP, if you're troubleshooting for MRP, just focus only on these, or like consider only things that take more than this time, some sort of guidelines?
There is
So to
no,
say.
to my knowledge at least, the silver bullet for that sort of thing, saying that these are the exact rules that you need to follow. Because if everything is taking a long time, it sounds like something. It sounds a bit.
Well,
weird.
it's not weird. Basically, it's just a very complicated BOM with the customer, and they are currently working with Microsoft too on that. So I just know that it's definitely not weird. It's how the customer works. They have a complicated BOM, and it has like a lot of child BOMs, and it keeps going under and between the technical and the business team. They are working closely with Microsoft as we speak, actually.
Okay, but then you have already narrowed it down to the complexity of the BOM being sort of.
So that
sounds like at
none of
least that
these-
is the root cause of your.
Yeah.
Of where we would start to look if we got this as an escalation.
Right, yeah. We haven't got anywhere, but yeah, thank you.
You're welcome.
Okay, so if there aren't any more questions, then thank you very much. I hope this was at least a bit useful. And hope to see you at the next sessions.